So this is the case. Being the medical director of your hospital, you are interested in understanding the relationship between the number of nurses on duty and the number of patients treated in that day. So the nursing service requested to hire more nurses to meet the quality needs of your patients. So they believe that having more nurses on duty may lead to an increased capacity for patients' care. So you ask them to provide with you a data on these variables over a week. So you want to see if there is a strong evidence that suggests the number of nurses on duty significantly influences the number of patients treated in a day at that hospital. So next is we will put them into table so that this will be transferred to your Excel. So for the first column, which would represent the X or the independent or the number of nurses, okay, and the next column, the other column, will be labeled as Y, which will become your dependent variables, or it is represented by the number of treated patients. So assuming that there is a normal distribution and the confidence level is at 95%. So the hypothesis will be, the null hypothesis shows no significant relationship between the number of nurses on duty and the number of patients treated. The alternate hypothesis will likewise signify a significant relationship between the number of nurses on duty and the number of patients treated. Okay. For this data, for this scenario, we will plot it on the Excel sheet. So it will look this way. So for the first column, it would represent the number of nurses, which is supposed to be the independent variable. And the second column will be the number of patients, which is the dependent variable. So meaning to say, it will the number of nurses positively project, okay, um, uh, cause and effect on the dependent variable, which is the number of patients. So that if you increase the number of nurses into how many fold, you can predict also the number of patients that they will be able to attend. Okay, so for the independent variable, it will be labeled as your x-axis and the dependent variable as your y. So given the number of nurses per particular number of patients, okay, the set of data was 3, 5, 2, 7, 6, and 8. So let's just check the um, number of counts. So one way to check if you have the good number of counts, you should go down here. So it means count of 6. Okay, so this is also count of 6 another way. So the first thing that we have to do is to find out if there is an interesting relationship that's going on between these two set of data. Okay, so first is we have to make a scatter plot. So you just have to highlight this one, and let's see if there will be a relationship. And the best way to show that is using scatter plot. Okay, the simple scatter plot. So this will be the result of the scatter plot. So let's see the relationship. So if we can draw a line, okay, uh, let's see, we can draw a line like this, then it seems that it has a positive relationship, right? It seems and it looks like it has a good relationship. So, meaning to say, maybe the prediction, okay, that you're going to do, which is the regression, will give you a good prediction result. So let's see the relationship using the correlation. Okay, so first is uh, we have to check for the value of R. Okay, so you still remember the R represents the per Pearson's correlation coefficient. Okay, so let's see the relationship using the correlation. This time, the Pearson correlation coefficient, which is R. Okay, so what will be the interpretations again? If your R is -1, so I just would like to remind you again that the correlation coefficient assumes a value between -1 and 0 and then +1. So the closer it gets to +1, that means the stronger the positive relationship, and the closer it gets to -1, okay, the more negative the linear relationship is. And if it is 0, it means there is no linear relationship at all. So that would be what we're going to um, uh, find out. So we have R, which is equal to correlation. So let's just say correl. Yeah. So if we take the value of your R, okay, it is equal to correl. Okay. So this will be your correl. Correl meaning to say it will involve array 1, which is your x, and then array 2, which is your y. So let's go first for your array 1. So let's just highlight this one. Okay. And then let's go for your array 2. Put a comma in there, and let's go for the array 2. And this will be all about this one. Okay. And then you just have to click enter. So what is the correlation? See, the correlation is 0.984951. So what does this mean? Okay, this means that it is closer to +1. So true to its form, okay, your scatter plot says that there is a very strong relationship, almost one, no, very strong positive relationship with regards to the number of nurses and to the number of patients that they will be able to attend with. Okay, so if we use this prediction, okay, um, we can expect, if we would like to see the causation, okay, the cause and effect relationship between the number of nurses and the patient, that if you increase the number of nurses, would also increase in the number of patients that they will be able to attend. Okay, so since we have a positive um, relationship, very strong relationship, so we are expecting a good relationship if we try to do the regression analysis, which is all about looking if this prediction, that if we can predict that if you increase the number of nurses, it will also increase to the number of patients that they will be attending. Okay, so that's the first part. The second part now is to do the regression test. Okay, so after knowing the relationship, and uh, we have a lot of information that suggests that we might be able to get a good cause and effect relationship with this. Now we can go forward to the next thing, which is to see the relationship between these variables, between two or more variables. Okay, so we will see if there will be if there is a changes in the predictor variable, which is your independent, okay, result in the changes in the outcome variables or the dependent variables. So with regards to our data, we're dealing with one independent or predictor variable and one outcome variable. So the type of test, the regression test that we'll be using will be the simple linear regression. So the next thing that we need to do is to find out the regression analysis. Okay, so this is how we're going to get the data for your regression. So go to your data, okay, and then go to data analysis. Okay, so these are your data. So here, so you go to data analysis, and then you click on regression, and then you click OK. So the input range will be the Y. Okay, input range will be the Y. So let's click in this one, and the input range X range will be this one. Okay, so again, you included labels, and your output range, you would like to put this one somewhere here. Okay, so after that you click on OK. So this will now be your summary output. Okay, so this is your summary output, and I will be highlighting the most important information that you should take note with this summary. So, so next is we will have to so next is we are going to interpret this summary output. Okay, so in the interpretation of this output, I just would like to highlight the four important areas that we need to consider. So let me just put a highlight on them. So number one that we need to uh, note is the R square. Okay, and then next is the significance level. Okay, the significance level, or let's see, doesn't make any sense. No? So it would be better if we will color it now. No? So I would like to highlight the the four important areas that we need to interpret. Okay, let me color that with yellow. No, so should have removed the click that. So this is your summary output. I would like to highlight the four areas that we need to interpret. Okay, so number one is this. This area. Number one is your R square. So I would like to highlight the four important areas that you need to consider. So number one is the R square. Okay, your R square, and then next is your significance level. Okay, and then the coefficients. Okay, the coefficients, which is particularly the x, not the intercept. Okay, the x, and then the fourth one is the p-value. Okay, the p-value, which is this one. Okay, so this is what we're going to interpret. So what does this mean? Okay, so let's remove that. No field. So what does an R means? Okay, the R square. What does an R square means? So R2 or what does an R square mean? So R square means it tells you how much does this data model explain. So with this value of 0.97, it would be better if this will be expressed in percentage. So 97%. Okay, so This means that 97% okay, of these data or variables okay, explains the existence of relationship okay, between these two variables. No? So if you can see, this is very high. So it gives a positive feedback effect on the possible result. Okay. Next is the significance level. Okay. So and of course yung observation pala. Please take note of the observation so that you will not be misled. No? So this should be colored yellow. So let's color it yellow. Okay, next is the significance level. Okay, so let's look at the ANOVA table and look for the significance level. Okay, so if you can see the significance level here is very low. It's around 0.000153. So it is equivalent to almost 0.00. Okay, so if we compare this with the significance level natin kanina na the p-value, the significance level of the null hypothesis, okay, it's 0.05, right? Okay, so this means that okay, the significance level of 0.001 okay, is way below than your 0.05. So if we're going to draw that again in a table, so this should be blue na lang. Okay, so if we try to draw that again, so your p-value for your test will be around here if it is 0.05, okay, and your significance value will be located outside, right? So it will be located here while your p-value is in here, right? So what are we going to do? What we're going to do, your null hypothesis will be rejected. Okay, rejected. So meaning to say, there is a significant relationship between the number of duty nurses and the number of patients treated. So aside from this, this shows that we have at least a good model. We have a good distribution of these variables. Maganda yung relationship niya. So it tells us more na magiging this is well represented. This model is well represented, okay, by the positive relationship. So even if sabihin na natin na yung alpha level of significance mo is 0.01, okay, still we have to reject the null hypothesis, right? Reject. So we have to reject, and then this one still we reject. And even if your significance level for your null hypothesis is 0.1, okay, so all the more you are going to reject your null hypothesis. So this shows that you have a very good model. Maganda yung distribution pattern ng cause-effect relationship mo. That if we say that if there is an increase in the independent variable, there will be a corresponding increase also in the dependent variable. So next that you're going to take note is your coefficient. Okay, so this means the relationship between the independent and the dependent variable. So this will describe the relationship between the dependent and the independent variable. So in this case, they have a positive relationship. See this? This is positive 10. So it shows a positive relationship. Okay, So we have positive there. And so positive 10 relationship. So in this case, they have a good relationship that when you increase uh, x, it will also result to the increase of y, or any changes in the independent variable will change the dependent variable. Okay, so this is what it means. So again, you have a good relationship for that. And the next is, let's take a look at the p-value. So the p-value. So the p-value 0.001. So again, given at an alpha level significance, which is with IP or alpha is 0.05, okay, and your test is 0.001, no? Is almost 0.1, 2, 3, 1. Okay, so meaning to say, again, when you take a look at this, your alpha level of significance will be, let's make it green para ma-identify nyo. Okay, this one falls here, and this one, this is a problem pag green, hindi ko na makita, will be located outside. Okay, so you're still going to reject your null hypothesis. So what happens now here is that given the significance level of 0.001 of the test compared to the null hypothesis, therefore what happens to your null, okay, your null will be rejected. Okay, so rejected, and your alternate hypothesis will be accepted. Okay, which makes sense, no? This makes sense that it already explains that yes, it makes sense that there is if there is an increase in the number of duty nurses would result into an increase in the patient treated. Okay, so that's how you're going to conclude. So if there is an increase in the number of nurses, you can predict that there will also be a corresponding increase in the number of patients. Okay, so it makes sense. So that's how we're going to interpret your given data. Okay, so again, in terms of this one, we have the you just have to plot them. The one variable, which is the independent, the number of nurses will result to more patients treated. So this will become the dependent variable. So one variable to one variable, this will be good for a simple linear regression. So the first things you have to see the relationship muna if they are related. If they are strongly related or there is a good relationship, then I think it is good to proceed with the cause and effect, which is the regression part. So first thing is you have to plot it in terms of scatter plots. So you have to see the relationship. So for the relationship of this one, you can compute it by R, which is equivalent to the Correl. So the result is 0.989. So very positive. It is close to 1. So it just shows that there is a very strong relationship between these two variables. So as early as now, you can say that any changes in your x will result to the changes of your y. Okay, So since we have a good relationship and we are expecting to have a good explanation on the cause and effect, then we can proceed with your regression test. So your regression test will be computed in a summary output. So you just have to click the data analysis, click on the regression, and then you click on the X array and then the Y array. And then if you click OK, so this will be your summary output. So again, there will be 1, 2, 3, 4, 5 points that you have to take note. Okay, so there will be 5 points that you need to take note. Huh? So let's put it in blue. Okay. Number 1 is the R square. Okay. Your R square will approximate the goodness of your variable. So 97% of the time, okay, you have a good sets of variables that you are treating with. Second is your number of observations. So does it tally? So 6, you can always tell the corresponding distribution of observation. And the third is the p-value or the significance level, okay, of your test, which is in this at this point your ANOVA, okay, if it fits, okay, it shows very significant relationship, then more or less you have a good, again, set of predictions here that you're going to predict. So ultimately, the way we're going to predict is to proceed with the fourth factor that you have to consider, which is the coefficient. Okay, so if this we will be more interested on the x than the intercept. So if this is positive, this means it is positively correlated. Okay, so there is a very strong relationship between the two. So ibig sabihin, there is a high possibility that if you increase the number of nurses, okay, it will also result to an increase in your patients that are being treated. Okay, so after this is you go to the fifth factor that you have to interpret. This is this one, number 5, the p-values, okay, of the test. So be particular that this you have to take note of this one. Okay, so the value is 0.0001, so 0.001543, etc., etc. So you have to compare with the alpha level of significance. So gumamit tayo kanina ng 0.05. Huh? So 0.05 is still bigger than 0.01. So 0.001 will go to the rejection region. Okay, and even if you put this one, gawin natin 0.01 or 0.10, okay, still it will be very significant. No, your p-value will still be on the rejection region. So what does this mean? Okay, the null hypothesis will be rejected. So it makes sense that you have to understand that alternate hypothesis will be significant. Okay, so we are going to accept alternate hypothesis, which means that any increase in the number of nurses will result to a corresponding increase also in the number of patients. Okay, so that's how you're going to do your regression and also correlation. So at least we've done a little bit of your correlation and regression. So that's how you interpret. Okay, so thank you.